Today we'll be doing Leetcode question number 7, how to reverse an integer. We are given a 32-bit signed integer, and we want to reverse the digits of this integer. So if we look at the examples here, we have 1, 2, 3. When we reverse that, it's 3, 2, 1. When we have negative 1, 2, 3, when we reverse that, we have negative 3, 2, 1. So the negative sign remains. For numbers that end with a 0, we ignore that 0 and we reverse the first 2 digits here. So for 1, 2, 0, we reverse it to 2, 1. And one key thing to note is that the number that we get might actually exceed the 32-bit integer range, which is negative 2 to the power of 31, 2 to the power of 31 minus 1. For numbers like that, we return 0. Say for number 1, 2, 3. What we can do is we can take the very last digit here, which is the 3. We can move that at the very front of our new number. Then we take 2 and we move this 2 right after the 3. So that will begin here. And then we take our final digit, which is 1, and we move that to the very end again as well. So let's see how we can implement this for the positive number case in Python. So because we don't know how many digits is actually in our number for x, we use a while loop. And we keep on looping until x is equal to 0. For us to monitor this process, we can use print statements, which will show us the numbers in each step of the loop. So first we want to get the last digit, and we'll call this last digit remainder. And we just use a modulus 10 to get that last digit. So we divide the number by 10 and we take the remainder. And here we divide the number by 10. The key thing to note is this integer sign. We want to make sure that we're not dealing with any float numbers, so that all integers and all decimal places are removed. Then we can print out the remainder. Now we add this remainder to our new number. The number that we output, we would start it with 0. And then we will move whatever is in our number forward 1 digit. So we multiply it by 10. We will reverse number up 1 digit. Then we add the new remainder to this reverse number. And then we set reverse as our new number. Now this applies to the positive case. What about the negative case? Negative case, it's the exact same thing, except we just add a negative sign to it. So we check if we are dealing with a negative number. If we are, then we multiply it, we make it positive. And we use a flag here to indicate that it's negative. And then when we return the number, we just multiply it by -1 if our original number is negative. Otherwise, we return the original number. So in this scenario, what we have here is we have it working for both the positive numbers and the negative numbers that are not out of bounds. Now we need to think about the case where it overflows. Well, first we set the maximum number and the minimum number. And we want to make sure that our numbers never go higher than these numbers. Now we check whether our temporary number, the number that we want to output, exceeds this number in every iteration of the loop. And why we check it for every iteration of the loop is if we actually store that number, that might cause an error. So we want to check and make sure that this number does not exceed our maximum integer or our minimum integer before we store it. So the reverse is greater than max int divided by 10. We cannot add a new remainder to it. Or if reverse is equal to max int divided by 10 and remainder is greater than 7. And this 7 that we have here is basically the last digit that we have in our max integer. So we can add a remainder of 7 and it will still fit into our max integer, but anything larger than 7, such as 8, would exceed our maximum integer. And if this is the case, we return 0. Else if, again, if our reverse is less than min 10, or reverse is equal to min 10 and remainder is less than negative 8. And this negative 8 comes from the last 8 here in the minimum integer. Then we return 0. Now let's test this out. Let's start off with a simple case, 1, 2, 3, and see what we get. So we do get a runtime error here if the local variable is negative, is referenced before assigning. So what I should do here is actually set the default for is negative to false. So if we look at our output, our first remainder is 3, and then 2, and then 1. And our x value starts off with 1, 2, 3, and then it becomes 1, 2, and then becomes 1. Now let's try it as a negative number. So this works for negative numbers as well. Now let's try it for a very large number, say this one. Okay, this number would not fit, because if we reverse this number, this would be larger than our maximum integer. So it should return 0. Right here, awesome. Now let's reverse this number and see what we get. We get this out of range, and it just says it's an invalid test case. So we would have to run our code to see whether it works for these large numbers. So what we have here is it works and it's accepted. So in terms of time complexity, how complex is this? Well, let's look at our code. We do a while loop for basically every digit within our number. So that roughly translates to a time complexity of O log x, where this log here is actually log base 10. And this number is roughly the same as the number of digits we have in x. And in terms of memory complexity, let's look at what we're storing. We're not storing any lists or any variables which are stored throughout the while loop. So within other variables within the while loop is changing and reiteration. What we then know is that the space complexity is constant, because we're overwriting the same variables over and over again, and we're not increasing the size.